we're going back to products, to a very important one, and that's trackers. The next speaker is Jesus Prado, who is a senior sales director at Nextracker, based out of Spain. And he talks about how to keep utility scale solar competitive in an inflationary environment that we have today in many parts of the world. Jesus,
Okay.
the floor is yours.
Hello, hi, good morning, Michael and team. Thank you very much for giving Nextracker the opportunity to be part of this event. Let me share my screen. Okay, can you see?
Perfect.
Perfect. So let me remove all this. Okay, so first of all, my name is Jesus Prado. I'm Senior Sales Director from Nextracker for Europe. I have been working Nextracker since 2015.
Wait, you might have to go again into presentation mode. I think you're now in.
Oh, sorry. Can you see now?
Yeah, but we see your PowerPoint signs, and so click on the bottom of presentation mode.
Let me see again. Okay. Okay. What about now?
And still not. I still see PowerPoint, your PowerPoint frame. Maybe click at the bottom to your right. Yeah, no. Yeah, but now flip the display settings, because we see basically your presenters display settings. It's at the top.
Okay.
And then swap you. And
Okay. Okay. It's nothing, something to. No, thank you, Michael, for helping. So I was yeah. I would say I've been working at Nextracker, senior sales director since 2015. Total 16 years in the industry. So thank you very much again for giving us the opportunity to talk about how to keep the utility scale solar competitive in inflationary environments. The points for discussion today, first of all, why trackers? We'll go quickly on a company overview and products and technology, and finally I will develop more on the tracker LCOE optimization. Now, a few minutes at the end for questions and answers. Well, on why trackers? I mean, the main reason on why tracker has expanded a lot in the last years is because basically the tracker has a lower LCOE and a higher RRR for the projects. So we are seeing how trackers are going north, are going to higher latitudes. In average, the tracker can produce up to 20 to 30% more energy than the fixed steel at only 5 to 10% higher cost. Then the tracker will have a better match in the utility load and will generate more energy during the higher use time. So we'll see later a slide on this point. And finally, the tracker will have higher performance on bifacial solar panels. In the case of Nextracker, we have a controller in every row. So we are able to have performance optimization at a row level. And this has also a lot of potential in the long term, right? Because we are implementing new findings, new developments retroactively in existing projects. So that's again a lot of potential to improve production during the lifetime of the plant. Now, ultimately, having a control per row, it's helping us to mitigate. It's helping the tracker to mitigate the risk from weather, snow, flooding, hail. We'll see a little bit more on this later on. You can see on the right the tracker daily power production in yellow versus the fixed tilt in green. So of course the tracker will help to widen the shoulders of the curve. This is important in two aspects. On one side, you can see below, this is the a capture of the curtailment happened in California Independent System Operator from 2020 to 2021, and we can see how curtailment in gray is happening especially at the mid of the day. No, so curtailment will impact more proportionally in the fixed output compared to the tracker. No? So that's a very important advantage on the tracker. Here, the second advantage, while we are seeing here the daily power output of a fixed tilt in brown, orange is the tracker, while we are overlapping to the electricity value, no, in blue. So we can see how in this specific case, while tracker is generating 25% more energy, actually it's having 31% more economic value, because you can see here in the yellow side, the right side, from 1 to 7 p.m. with a peak time period of electricity price, the tracker is actually producing 48% more energy than a fixed tilt. So that's and this type of comparison is becoming more important now, no? Where we are becoming more specific in the production, the electricity pricing evolution during the day. Now moving to company overview, Nextracker has kept number one tracker manufacturing in terms of market share with around 30% since 2015. We have shipped so far 75 gigawatt of projects, up to 100 gigawatt under fulfillment. Nextracker belongs to Flex, one of the largest contract manufacturer worldwide. We have 700 employees worldwide, with a strong office in Europe, no, based in Spain, in Madrid. We have 50 people covering all the disciplines. We are expanding a lot at the moment in Europe. Important milestone is Nextracker went public in NASDAQ in February this year with the highest market cap of all the trackers. No? So financially, we are the most stable tracker manufacturer at the moment. And Nextracker has the NDA of innovations in day one. So we are the first tracker with individual row versus the legacy link row tracker at the moment. We have applied a tracker without any plastic components. It's a self-grounded tracker, equipotential. All this is adding cost saving to the equation. We'll see later. We launched our self-powered tracker back in 2015. So we have deployed a big 65 gigawatt of project with self-powered tracker. And we have developed software products, smart control with True Capture and Navigator. And finally, this is also very important, I will develop a bit more later on our terrain following tracker. No, this is helping also to reduce total install cost. At the moment, especially in Europe, we are focusing on one portrait product. We have our Nextracker Horizon, our standard tracker, and at the same time, we launched in 2018 our terrain following tracker, as I mentioned. We are also focusing on our software products with True Capture and Nextracker Navigator. On one side, the True Capture will help to increase energy yield up to 6% in some cases, and Nextracker Navigator is helping to improve the monitoring precision. No? So we are helping the operator to be more precise in the tracker monitoring. No? That will help to better planification and total reduction of the operation and maintenance cost. In Europe, at the moment, we have over 4 gigawatt of project deployed, especially in Spain with around 3 gigawatt, and the south of Europe, Italy, Greece, Portugal, but also trackers, as I was saying, are going in northern latitudes in UK and Denmark, and we are having our first references in East Europe, no, Romania, Hungary, Poland, etc. Before jumping into the LCOE optimization, this is a very nice report issued by Irena lately, no, on renewable power generation cost in 2022 compared to 2010. No? So we can see in yellow how the solar PV total install cost decreased significantly, dramatically from 2020 at over $5,000 per kilowatt, down to below $900 per kilowatt in 2022. So while we have been in an inflationary environment in the last couple of years, solar PV and tracker has continued decreasing cost in the last year, no? And also in the last couple of years. Capacity factor increased from 2010 to 2022 from 40% to 17%, and the dramatic decrease in LCOE in solar PV from 44.5 cents per kilowatt hour to less than $5, and in some cases less than $3 cents, as we are seeing at these record LCOEs. On the figure on the right, we can see the share of each component on the solar PV plant to that cost decrease. So of course the module has supported the majority of the decrease in terms of percentage. As average, tracking and racking has implied around 7% of total decrease. When I see pricing, when I compare pricing in 2015 to pricing now, I can see tracker price reduction in some cases up to 50% from what we are seeing now. Well, of course, customer care about LCOE. That is what defines the return of the investment. The capex, as I said, is a trap. No, capex is a trap for the entire lifetime. 30. We are saying increasing lifetime to 30, 35 years, 40 in some cases. So Nextracker is providing advantages and is helping optimize LCOE cost at all three levels. CAPEX and OPEX reduction, and also increasing of the energy output. How we can get there, we will see. First of all, we have, I would say, the best mechanical system, tracker system in the environment. So we have a self-balanced mass design that is aligned the center of rotation and the center of mass, which is the module line, right? This self-balanced mass design allow to reduce the total power required by the motor by in less than 50 watt. It's also allowing us to go to longer rows. We can apply up to 4 strings per row. We are also deploying pre-assembled components, applying rivets, right? It's vibration proof. You know, it's faster to install and does not require maintenance over the plant lifetime. We are going to extended rotation range to up to plus minus 60 degrees. This compared to other trackers can produce up to 1% more energy. No, so this mechanical design, the structure of the tracker will help to reduce CAPEX, OPEX, and increase the output. One important point is the wind engineering. Sometimes it's thought to be a given a feature of any tracker, but it is actually not. No, so back in 2017, we released a white paper on wind engineering and defining the aeroelastic effects of the tracker, which was more, you know, a confidential issue and something not well defined in the tracker industry. These pictures on the right is a very famous case and sad case in Australia, no, where there was a extensive damage in a competitor in a specific wind event, not necessarily very high, while Nextracker was completely undamaged. No, so we have been working to better understand the tracker behavior in outdoor conditions with CPP for the last 10 years. We are validating, this is very important, in full-scale outdoor wind testing in a facility in Colorado. So we can actually, we have full scale. It's not the scale models done by wind tunnel engineering, but also at full scale. We're able to analyze up to 15 modes of the dynamic analysis, and all this effort is translated into results in the field. So we are not seeing a structural damage in any wind event with very high winds in all our geographies. So that will translate into OPEX reduction, of course, because this is very expensive to correct these failures and also increase output. Something that I think is not well developed right now in the industry is how the developers capture, in this case, tracker uptime. How Nextracker in this case is helping to deliver what promise, right? So there is we are seeing, talking to certain long-term owners and the developers, we are seeing how the trackers certain trackers are not complying with a minimum quality, a minimum uptime. That will be impacting the business model, the P&L of the projects. So wind engineering is a crucial part of this. I was mentioning about Nextracker Horizon XTR. This is a terrain following tracker. Now, grading and environmental impact is a big issue right now, especially in Europe. We are seeing how environmental impact assessment and declaration of impact are limiting the amount of grading that can be done in a site, and in some cases not allowing any grading at all. So with Nextracker Horizon XTR, the terrain following tracker, we are able in some cases to eliminate up to 100% grading. We are also able to reduce total pier length. And of course, this will translate, first of all, in permit compliance, right? That's basic. Second, we are able to reduce total install costing of the tracker and the project. And third, we are able to, this feature is able to reduce the total construction work. In a moment like in Spain, where there is a very high demand of EPC installation, construction, and in general, a labor shortage, this is very important, right? We are reducing construction time that will allow to the EPC and to the installer to finish the work and move to another project. This is in relation to the grading and the XTR. We can see on the left a standard tracker heat map. This is the areas affected by grading. On a standard tracker. On the right, we can see areas affected with the Nextracker Horizon XTR. This is a very dramatic topography area case in Portugal, 270 megawatt case. We have been able to reduce 65% in grading volume, which is 1 million cubic meter between cut and fill. Imagine, the time and cost behind this 1 million cubic meter. Then we go to the energy side of the equation. So what we say is it's important to model correctly the tracker architecture in PV system because it can lead to different energy production, especially on the bifacial. Now, in the case of bifacial, in this case for Nextracker, we are able to produce 1% more energy by separating the module from the torque tube. That will help reduce the total shade backshade impact and reduce mismatch losses. We do not have panels over the gears, bearing, piers, etc. So that will help increase the transparency of the system while reducing backshade and mismatch. So that will in a well or on an accurate PV modeling, this is translating, depending on the case, the albedo, etc., up to 1% more energy. So of course, reducing the total LCOE. Our control system through capture is helping to adapt the tracking to the site conditions, and that will help increase production with two components. We have the diffuse light tracking on the left. So basically, applying dedicated GHI sensors will measure the amount of diffuse light, and after certain filtering, our trackers will go to diffuse light tracking. So that is not necessarily flat, but reducing the tracking range. And by that, we will be able to maximize production on diffuse light. And then the other component is the row-to-row tracking. And the idea is to eliminate shading, or let's say to optimize shading management. And then we have two modes. First of all, it's a full shade avoidance mode. This is applied when there is a full cell module. So the strategy there is to completely avoid inter-row shading. And then the second mode is the split boost mode. So in that case, we are allowing certain inter-row shading. So the best strategy there is not avoid completely inter-row shading, but maximize production in the upper part of the module while allowing certain shade in the lower part of the module. We can better see in this picture, right, where accurately we are allowing in this slope changing side. The shade can go up to the half part of the module, while we are maximizing production in the upper part. So these type of half cut shell modules are basically working like two independent modules thanks to the diode structure. Again, translating to increased output. And the most important to capture is the bankability potential. So we have been working with the majority of the independent engineers of the industry. Most of them are able to validate or calculate independently the energy gain of true capture in a pre-construction stage. And they have proven a very good correlation between the energy calculated in this commercial pre-construction stage and the energy generated by true capture in the operation stage. So the long-term owners are able to translate this true capture gain into NPV. So there's a net present value of the true capture that can be captured in the business model of the plan, and this is basically a project that will produce more. It's a more valuable project. This is I would say a trending topic. We are seeing more and more impact due to extreme weather. So our monitoring and control system is allowing to manage severe weather risk. On one side, flooding is important in certain areas, and we have a specific flood store strategy to minimize impact. Hailing is becoming a big issue, especially in some areas in the US. I would say Texas, Kansas, all the Midwest part. So we have a specific one-click hail store strategy. We'll see a little bit more later. We are able to, thanks to our wind engineering, to withstand, let's say, normal winds during the year, and we are able to prepare the tracker for a hurricane. We have a lot of projects in the east coast of the US that are being hit by hurricane periodically and with zero damage on the tracker. And finally, also very important, Nextracker is able to withstand highest snow load at the same time of highest wind loads. We are also very well prepared to a grid outage, with our integrated backup power. This, of course, will translate into reduced OPEX, so no damage or less damage on these extreme events, while increasing the uptime, increasing the output of the plant. In terms of hail and hail store strategy, we are able to, I think we are the fastest tracker in the industry to go into stop position, less than 90 seconds. All the plant go to a stop position, so that is minimizing any impact with wind and also with hail. And our stop position at 60 degrees reduce has 40% less impact energy by hail versus other tracker that can store at 50 degrees or even less. So there's some other structures that are more horizontal that will ensure like big impact, as we can see in the picture, in this project in Texas in December 2019. So we have 17 gigawatt of projects deployed in hail regions, and these projects are applying this specific hail store strategy. Finally, last slide of the presentation, we can get time for a few questions. I think it's important in these times of volatility to have a very diversified supply chain, right? We have localized production in the main tracker regions. Here in Europe, we have working with a lot of suppliers, right, to localize the supply chain, and we are able to de-risk any logistic issues as we have seen during the COVID, and also it will help to reduce the total landed cost of the tracker. Okay, that's my presentation so far. Thank you very much for your attention. Please let me know if there are any questions.
Thanks, Jesus. Very nice overview. So from my side, so how you see the development actually in northern countries? You've seen now there was a system in the UK and Denmark, and so and what's needed actually to accelerate the use of trackers in that regions?
Right. So yeah, I mean there is more attention to tracker in those northern regions. So we are seeing higher demand in Nordic countries as well, right? Sweden, Finland, Denmark. We are seeing higher demand in the UK. Some of these projects may have a special financial, let's say, facilities or financial support with the tracker. But if you're doing an accurate and a more advanced modeling of the tracker production during the entire lifetime, we can see that tracker can make sense in those geographies. No, so things like true capture are helping to increase production, right, versus a fixed still. So to maximize the production on these cloudy days, which is important in the northern geographies, and bifacial also it's helping to make the case towards the tracker. So that's something that will help to again to make the tracker competitive in the northern latitudes.
Okay, maybe one more. So here's one question: what's the latest structural trend in the tracker industry you see?
Well, I mean, we'd like to develop a little bit more in that sense, no? But we have been, I would say, for us, we are making out of focus first of all in the control, as I was saying. I think there's still a lot of room to improvement, no, to optimize how the control of the tracker is done. No, we have control per row, and that has a lot of potential. So what happened with the bifacial production, or can we optimize bifacial production by adapting to a better control? We are also in large utility scales. We are able also to even adapt the tracking to the specific like weather conditions. So we are seeing how the clouds go along the side, no, and in a very accurate controlling, we are able to place each tracker depending on the amount of irradiation it's been received. The other structurally, we are trying, of course, to optimize costing, no, while keeping a responsible design. So the most important is keeping the stability with the wind events. So while keeping the dampering, the dampers in the structure, we are able to go to longer rows. So it's important to optimize the application of electromechanical components. So going to longer rows while again keeping that stability. And then so that is and then again, what is the impact of the tracker in the other components of the plant? No, one very important impact is the civil works, and we are working with the Nextracker Horizon XTR, so it's minimizing grading. We will be launching products with a higher tolerances of grading, but also what is the impact of the tracker in the cabling, right? So there's something more development to do And basic idea is to see the power plant as a whole. No, at the moment it seems that we are seeing the power plant as silos, no, as components: the inverter, the module, the tracker. The idea is to see the integration all together.
Okay, perfect. I think there's 2 more questions in the chat. If you still have time, you might want to actually answer them there. Otherwise, thanks again, and we continue with the next presentation.